My name is Vienna Unamba and I work in the University of Hertfordshire as a Senior Technical Officer in the Civil Engineering Department. So in the fluids lab we have the FC80, which is the sediment flume, and students who use it are basically students who do like fluid mechanics or hydraulics. It's very important to do practicals. You just like taking the real life situation and scaling it down to see how it will, how it works, so you can actually have a visualize how it's going to look like in the real world. So for the flume, for example, it's an open channel, so you actually see how materials are transported when the sand, when you go to the sea and you see how the beach and you see the sand there, so you have an idea of how this actually happens over time. Okay, so now we're going to show you around the equipment, show you different components, how it works. So this is a sluice gate. It's used to close up the flume, not to allow water to come in. So it's like I stop this and no water goes in. And this is a depth gauge used to measure the depth of the water. This is a dye injector, which is used to inject dye into the system. So you see how the dye goes in, the flow of the water mainly used to show how the water flows, especially when it's turbulent or when it's not. And this is the wave generator. It's used to generate waves, as you can see now. This component here measures the flow rate, and the flow rate we can switch it and tweak it. This is a depth gauge, another depth gauge. We have one at the upstream and another one at the downstream. So, and this is our flow switch. This flow switch stops the flow of water immediately the water gets to a high level, so we don't have an overflow in the lab. And this is another component here that we use to stop the sediments from moving while we fill in the sediments. Okay, so now we have a sieve. The sieve is connected to the tank, and once we collect all the sediments into the sieve, we can take the sediments out, and this water can be recirculated back into the system, and then the system keeps going like that. So we don't have to fill in more water into the system. We just have the tank, we have the water, and it recirculates in the system. So with a wave generator, we can actually create a trough and a crest using the sediments in the flume. So it can be created over a long period of time depending on how the intensity of the wave generator is, because this is meant to transport. Normally what water does, water transports materials. So we're trying to measure how fast or what time it takes for the sediments to be transported, and what kind of shape it gives at the end. It might turn out to be a dune. We have to measure the crest and the trough, how deep, how high. We have the two flumes here. This one is a sediment flume, and the other one is just a 5-meter flume. This flume is without a sediment, so you can do everything. It's easier to say, oh, the final year student can use it for anything, but mainly this is for research, and it's for students who really, really, really want to use it, because it's transportation. It just shows how water transports different things, not just sediments, but you can actually use different things in the sediment flume. Using it has been very straightforward. I just came into work and they just told me this is how it works, and it was easy to actually go through it. But for this flume, we had someone come in to tell us how it works, and afterwards, most of the things we do, it's easy to fix everything in, and it's easy to just okay, this is how the button works, and it comes with a manual. So it's easy to just go to the manual, read through it, and then you can be able to walk it through. And then for the blue dye, it comes with the blue dye. It makes it easy for you to measure whatever you want to measure. So it's really relatively very simple to use and straightforward.